everyone. We have Miguel Dickson here today. He is the head eye of data and AI RoadBotics. I'm going to turn it right over to him for the next 20 minutes. If you have any questions, you can put them in chat and we'll take those at the end. I'll help monitor it. But Miguel, take it away.
Sure. Hi, everybody. So my talk today is going to be kind of a seeing the trees in the forest talk. I know that sometimes a lot of these conversations around AI and ML take place in a very high context, but I think that sometimes folks often, especially folks who are not directly with the engineering side of things, sometimes don't know, like, okay, what's the boundary between like where product begins and ends and where the AI and ML part comes in. And I've often found it's useful for folks to get kind of a sneak peek of like, okay, what part of this is software, what part of this is design, what part of this is product, and what part of it is AI and ML. And I think what you might be end up surprised by my talk is what a actually like scalpel surgically precision precise small part of it is actually the AI and ML, at least for our application. But I think the flip side to it is seeing that a ton can actually come out of a very, very, precise application of ML. So without further ado, let's jump right in. So motivating question for this, right, is basically, what is ML for, right? What does it do for a business, right? And ignoring for the moment the research for research's sake argument. There's lots of ways to approach this question, but I found that in practice, there's one very simplifying way to look at it, which is basically successful use of ML is going to be no different than any other business process. It really works for a business when it gets you something cheaper, and so often you get a lot more of it. It's a scale factor. Or it gets you something done faster than in a way that is traditionally doable, or better. This could be like higher accuracy or more completeness or something. And unfortunately, the sexiest of case, which is the only way to do something, might be true or might not be true, because it often is true that doing something at scale turns into a qualitative difference. If there's only one way to do something 10, 20 million times or 10, 20 billion times, it turns out that that might be a qualitatively different way to do something, even if quantitatively each individual step is something that you probably could already do. Now, that sounds, maybe a little abstract, but hopefully the cheaper, faster, better, more idea should ring true to you, right? Like this is generally like if we're looking for business process improvement, we're thinking about those kinds of things, right? So let me warm you up with a kind of simplified version of the problem we're going to look at for the case study today, right? And this is kind of like in the RoadBotics space, and we're definitely moving into this, but this is kind of a toy problem, but you'll see very quickly that it's not a toy problem, right? So stop sign identification and or accurate identification that you don't have a stop sign in a particular place is a valuable service. How do I know it's a valuable service? Because A, municipalities need to know if stop signs are missing, and they can be held liable for quite a lot of money if they've been made aware or should have been made aware that there's a stop sign missing. A little background for me, I actually used to be a lawyer, and I'm well aware of like the actual liability thinking around this kind of thing. But the unfortunate truth is that for a lot of cities, this is often done on an ad hoc basis. Basically, you know that an accident happened and took down a stop sign, or somebody called their 311 service or something similar. Somebody complained about it, and that's how you know that there's a problem, right? So another way of thinking about it is say, okay, we're in an AI digital age. How would we solve this problem, right? So as a simplifying assumption, assume that you have pictures of every intersection in a given city. And by the way, that's not an easy assumption. The number of people who I've talked to who are DPW or municipality heads, so I say, do you have a picture of every intersection in your town? It would be look at me like, is this a trick question? Obviously not, right? They might think about like Google Street View or something, but often the data there is of widely varying temporal quality, right? It could be the latest view was taken in like June of 2013, or it could have been taken yesterday and you just don't know ahead of time, right? Which is not very helpful to the problem, right? But let's assume that you had all of these pictures on hand and handy. What could you do with them? One thing, and technologists will jump to this is kind of the like, you're in the AI/ML space, is the first thing you're going to think of is, okay, let's train a semantic segmentation model. And for folks who don't know what that specific term means, segmentation just means you're going to take a picture and basically break it apart into like meaningful parts. So those are the segments. And semantic just means you're going to apply a human meaningful label to it. So like car, sidewalk, stop sign, right? And a machine learning model that does this in computer vision is called semantic segmentation model. AV companies basically do a ton of this, and it's still not an open and shut technology for most cases. looks something like this, right? And you can kind of think, okay, well, I train a stop sign detector, I run it across all my images. That might be a way of getting stop signs, right? Another way you might think about doing this problem is to use an existing one. Real technologists are like, why would I train my own stop sign model? Somebody has to have done the technical legwork for me. I just want to apply it, right? So in this case, yes, Detectron 2, this is a Facebook trained neural network, and it's often used for the common objects in context, has you covered. And it's pretty cheap to use, right, and train. But understanding the limitations of it is itself kind of like a weird technical game. I don't want to linger too long on this one because I have a funnier solution in mind. This is super old school technology. Detect how many pixels are in each image, figure out if they're roughly in an octagon shape, and do OCR for the word stop. And then figure out any edge cases manually. You can do this incredibly cheaply. We're talking like a billion images. You could probably do it for a few cents of CPU processing and get really high accuracy, right? But it turns out that all three of the solutions I talked about are all going to fail in basically the same way. This is actually a legitimate stop sign. So is this one. And so is this one, right? And the funny part about this is that these are not technical failures, right? In the case of the semantic segmentation model, you probably didn't train it to look for the object in the middle, right? In the case of OCR, your likely English-speaking developer probably didn't think that pare would be stop and that he should check for every possible foreign language translation of stop, right? And for your red detection model, you might not have known that stop signs can come in blue, right? And it turns out that all of these, actually the answer to all of them is a product question. Are you selling internationally? Do you need to detect various versions of stop signs? Do you care about customizing your product to various international markets? Or do you know exactly the kinds of signs that you're interested in detecting, right? So it turns out that, again, a lot of the interesting business questions are going to be less about the application of the technical model, right? I gave you an ML version, but I also gave you two very non-ML versions of solving it. But the product context is really what's going to make or break the application here. And with that, I want to talk about the case study that I promised to talk about, which is one of the products that my company uses, sells, made, RoadWay. And I kind of want to do an interesting little exercise here in terms of talking about where is the AI and where is the product, and why does selling it as the AI both accurately describe the key technical point, but also kind of miss the forest for the trees, right? So looking at this as a case study, right? We begin with an observation, right? Accurate, comprehensive, timely road condition data is valuable to have. Municipalities want it. They're willing to pay us for it. We actually know that post-fact, but before building the company, we did a lot of product research to find out that, yes, people were going to be willing to pay us for this, right? And you might notice some implicit like callbacks to that first slide about better, cheaper, faster, more, right? Accurate generally implies expensive, right? The traditional way of doing this is basically having civil engineers look at your roads, which implies paying civil engineers to do something. And that's expensive. It's expert labor, right? Comprehensive also is a slow and expensive kind of thing when you're doing it as a manual process. Using civil engineers to assess your infrastructure manually is going to be very expensive. And generally timely. Without some way of basically expediting the process, you're basically stuck where, I think Courtney made a reference to this in the prior discussion, but basically somebody driving around in a truck with a clipboard or with Excel and basically writing down these things. It takes a very long time to do. In our practice, we've actually seen real turnaround measured in quarters or years. So this is like the road survey that we made an RFQ for in 2017, got done in 2019, and we got the data delivered in 2020. So 3 years old or 2 years old by the time you get the data, which, by the way, in road surface time, it takes a month to spawn a pothole. Sometimes a day of bad weather, like a freeze-thaw cycle, will spawn a pothole. 3-year-old data, a street could look perfect 3 years ago and look like garbage. Something that happens relatively frequently in Pittsburgh, actually. Right? So let me talk about basically what composes RoadWay, right? So I talked earlier about the stop signs basically needing the you need to have data, right? Turns out the same thing would be true of roads, except more so. So we solved for getting basically fast data collection. And we basically said, okay, let's do a smartphone app that takes relatively high definition video of the road surface and basically make it really easy to use so people can just slap it on their dashboard and go driving. This is a relatively fast way of developing the information you need for the solution, not AI. Once you have a picture of a road, right, which we extract from the video, you want to be able to automatically tell what the condition of it is without basically asking a civil engineer. This is the AI part, basically the model that takes this picture and says, this is a 5. If you want an explanation for why it's a 5, that little kind of like pattern that you're seeing in the front, that's called alligator cracking. And even though it doesn't look like it's particularly unpleasant for your car, what it actually means is that the subsurface has eroded so badly that the weight of the road itself is cracking it, right? So this is like if you've done some kinds of baking and like your top layer is too heavy and the weight of it itself actually just cracks it. This is basically the same thing that is happening with the road surface. And our model knows this and can basically say, this road is in really bad condition, right? And then you don't want to look at 50,000 pictures of these in a Google Drive folder. I promise you, it's not an engaging way of like looking at this, right? So the vast majority of our time as a company has been spent basically developing a tool. And this is basically our Google Maps version of how to look at this data, right? You can tell that it's, in essence, hundreds, thousands, tens of thousands, up to tens of millions, depending on the size of your city, versions of the prior slide, right? It's the photo, it's the rating, right? But then there's a ton of work basically geolocating these things, giving you an interface, giving you filters, giving you a way to like virtually drive down the road and see the changing conditions. And all of this is not AI. Okay? So, you know, kind of like looking at this from the top down now, instead of from like the inside out, you've broken down a complex product need. Somebody would like to have a really easy to use, comprehensive data set in a geospatial format. And the easier that you can make it and the more powerful, the better, right? That's what they want to buy from you. They don't want to buy, this is a machine, a black box that turns pictures of roadways into integers. But that's the machine learning part, right? It turns pictures of roads into numbers. I mean, there's a little bit more to it than that, but really, honestly, not that much more, right? The key AI bit is computer vision. And then this is basically the more and the faster and the cheaper. We promise ratings every 10 feet, right? That is basically a wildly controversial thing to do in our space, right? The current state of the art is basically looking at a representative subsample of a road surface. You basically go out and you survey like 20 meters, and then you basically say, okay, I think this is relatively representative of the next like 1 or 2 miles. So that's what I'm going to assign this road. That is actually the prevailing standard. It's called ASTM D6433 Pavement Condition Index. It's basically the actual industrial standard for doing pavement assessment. And it says basically, pick a small segment of your road and assume it's pretty much the same for that area of the road. Instead, we say, no, we're actually going to basically rate the road everywhere. Every 10 feet is basically a car distance in front of you. It is effectively the same as literally everywhere, right? For even a small town like our neighbor Dormont, it has 30 centerline miles of road. That's 15,000 images to analyze. You could not pay a civil engineer enough to and say, okay, I want you to sit down and I'm going to give you a bucket of 16,000 images and I want you to write 1 through 5 for each of them. This is your job for the next 2 months, right? It's just too expensive, too slow to do by hand. But it's what we describe as a embarrassingly parallel kind of problem, right? If you have a computer vision model, you can basically break this apart into any number of servers doing this, any number of workflow platforms, and as long as your computer vision model does the trick, you can get this answer back as fast as you want. But why do people buy it? Because of the tool. It's not the AI or the model. It's the product, not the machine learning. And it's the market need, not the technology, right? And this is kind of the key insight in bringing academic innovations in machine learning, basically from research papers to products, right? You have to think, okay, what is it that somebody's going to buy from me? And what the DPW wants to buy from us is the map. They want the web interface. They want to log in and see their entire city at a click. They don't really actually care about how we got there, just that it works and it's cheap, and it's better. And then other things to kind of think about, and these are things that my company basically lives and breathes. Quality control, right? I just said that there's 16,000 images. Anybody here who knows anything about machine learning knows even the best models working in the simplest contexts have errors, right? Even your bank ATM, when you write a check and scan it, will occasionally have errors, right? How do you deal with quality control? How do you deal with remediation? What's your SLA? Like, what's your service level agreement, right? If we say that there is a pothole on the corner of 24th and Butler or something, and we're wrong, what does the customer think? If we tell them every other pothole we found for you looks good, is that good enough? Is it not? How do you deal with redundancy or ensembles, right? Human on models, do you have human overseers? Do you have models overseeing what the humans do? Do you do models on models? Is AI the right answer, or even just the first answer, or the cheapest answer, or the fastest answer? And I promise you guys to keep it short and simple, and that's pretty much it. We can stop here if folks have questions.
Any questions at all that you want to type in chat? I'd be happy to represent your questions. That was phenomenal, Miguel. You're engaging as well as informative.
Thank you.
I'll go ahead and bite, Miguel.
Sure.
You mentioned, I would not be pragmatic to pay a civil engineer, to rate 16,000 images, of course, 2 months, which I would agree with you. I'm curious how you kind of, a lot of obviously models have some sort of training process required where you do have to at some point pay someone to tell you to teach your machine. So I'm curious kind of how you weigh in that kind of training process into the product and almost ROI kind of thinking for your product.
That's a great question, Nate. So it turns out that one of the fun things about machine learning is that you don't actually escape having to do that. You just escape having to do it many times, right? Like each time for each delivery. So in some of the nitty gritty detail, basically, how does that model work, right? I just kind of abstracted and said, okay, we have a machine learning model and it does that. So basically the way it does that is we basically got our expert board, who basically has a lot of civil engineers, as well as some civil engineering expertise. We basically taught ourselves how to do the assessment standard and basically developed a large training corpus that we ended up doing this basically, right? We as a company. There were people sitting in front of images and saying, okay, this is a 5 because X, this is a 1 because X, this is a 2 between X. And then we ended up basically developing some, I hate the word synergy, but it's really the right word, or like positive feedback loops, basically, where our QA would basically end up feeding back into our labeling system, right? So basically we would do QA of our results. We'd figure out where the model was doing badly. We would then actually label those images. And then basically as you repeat this cycle, you basically hone down the areas where your model is doing poorly and you need to basically focus your quality control efforts. And then also kind of the flip side of it is that as you get better at predicting what your model will do, you can also get better at predicting where you need to do better QA, which is kind of a very deep virtuous circle. But yeah, basically we did this once and it was exceedingly painful, and we still do it to some extent. We now just do kind of like iterative improvements of that training. And then obviously when we want to develop new computer vision capabilities, we have to basically do a version of this process again. But luckily, for instance, for our customer Detroit, who had literally millions of images, like labeling those by hand is like, you sit there and do the pocket calculator math and you're like, yeah, no. Also, like, just, it's horrible. It's mind numbing. You actually have to kind of space it out because we actually did statistical tests to basically see how consistent we were with ourselves or with other raters, and realize there's only a very small amount of time you can spend doing the task before you start wildly diverging with yourself or wildly diverging with others. So for instance, if you've been looking at roads and they're like very heavily potholed, Pittsburgh, then almost any streets anywhere else just look like these sparkling, beautiful streets. And then if you start with those, right, you start noticing little defects much more easily. And that's actually part of the subjectivity problem that DPWs have with their current work.
Thank you so much, Miguel. We have 2 more questions from the chat. That was a great question, Nate. Jack said, how long has RoadBotics been doing this? And Goodell says, have there been any requests to forecast where the next high severity repair will be needed, or what may be causing the most severe defects?
Okay, I'll handle the easy question first. How long have we been doing this? The company's been incorporated since December of 2016, and our first paying customers were in early summer or late spring of 2017. Our first customer is North Huntington Township. So always like to give them a shout out when it comes up organically like this. So yeah, basically since 2017 as like a purchasable product, since 2016 as a development. And of course, the science behind it, Christoph Mertz, one of our co-founders, was working on this for several years beforehand at CMU. And then, have there been any requests to forecast for the next high severity repairs are needed? Yes, absolutely. But it's actually one of the interesting things that we kind of leaned into in a product context is that folks are always a little bit leery of things that promise to take their jobs or basically promise to render expert judgment for them, right? And one of the nice things about what we do is that we take a task that literally nobody wants to do. Nobody enjoys collecting the data. Nobody enjoys doing the initial assessments. It's just tedium. It's like backbreaking work. And we basically say, okay, here's a really easy way to do that. How you're going to spend your budget, a lot of the more kind of like in-depth engineering analyses about like, why is this particular road having trouble? It turns out that that is a lot faster and easier to do with our tool. Like if you basically can virtually walk down the road as a civil engineer, you can say, oh, I think this is like a drainage issue along this side of the road, and that's probably why this side of the road is deteriorating, etc. But a lot of those things are much easier for us to provide tools for experts to actually use. So like decision support for civil engineers that are already there and already have deeply embedded expertise than for us to do. We do have a few predictive models that we've been working on, but in practice, almost always, there's so many other types of constraints on what folks do. And again, like budget, politics, the capabilities of their own crew, what they subcontract versus what they do in-house, that most people are just happy to have better data.
All right, it looks like that's all for the questions. Thank you so much for your thoughtful answers as well.